Are we going to work? Hello? Are we going to play? Are we going to be able to play Sudoku? Please, I hope so. It's very fun. And we're going to solve some amazing puzzles today. As you can see on the board, this is kind of a crazy, insane puzzle for anyone that hasn't seen Sudoku before. And this is only my second time playing variant Sudoku, so fingers crossed we can figure this out together. And if you do have any suggestions for either Sudokus, crazy variant puzzles of any kind, or just we're solving one and you think you know, let me know, because I love to solve these together. But basically, yeah, there's no numbers in the grid at all. So what the hell are we supposed to do? Well, this is where these crazy rules come in. If this was a regular Sudoku, well, that clearly wouldn't work. But it's not a regular Sudoku, so luckily it does. There's some genius trickery going on. And I've collated a few of my favourite puzzles that I've seen but haven't solved yet, so I'm not completely blind. But yeah, I don't know. This could take a while, or they could take a few seconds. Hopefully, they won't take too long, but we'll be able to solve them together. So, first of all, the thing I noticed immediately is this is a 6x6 Sudoku, so it's going to be slightly easier potentially. But then it also has this, like, the boxes aren't boxes, which is also kind of weird. But I think hopefully okay. Hopefully still figurable outable by someone that hasn't done these before. So what are the rules in a random variant Sudoku? Well, they're always different, but luckily they are written on the right here. So normal Sudoku rules apply. So we still need to put the numbers 1 to 6 in every box and in every column and row. So that's still good. We understand that part. I understand at least that. And then digits adjacent to the black dots are in a 1 to 2 ratio. So what that's going to mean, I'm assuming, we did these a few last time, that's going to mean that if there was a 2 here, for example, then this would have to be a 1, because the 1 is half the 2, or a 4, because it's double the 2. So kind of one of the numbers on a black dot just has to be double the other one. And that worked out nicely, and that's a nice way of looking at it, I think. This 1 to 2 ratio is a bit confusing. It doesn't need to be that. It doesn't need to be that insane. And then digits along the thermometer must strictly increase from the bulb to the tip. Now, that's actually quite a huge restriction, because you can see we've got thermometers of length 4. We only have 6 numbers. I mean, the 7, 8, 9 are technically here. You know, the 7, 8, 9 are technically here. But it's a 1 to 6 Sudoku, so we don't actually need to use the 7, 8, or 9. And we have to have 4 numbers that increase. So if this was, a 3, this would have to be a 4, 5, and a 6, because the numbers go up. And these are actually exactly what the numbers would have to be, because if this was a 5, let's say, because they don't have to go up by 1, but they do have to go up. If this was a 5, then this would have to be a 6, because it can also be a 5. And then we've actually not got anything to put on the end. So already I'm saying these are quite constricted, because now this means this can't be a 4, because again, we'd have 5 and 6 to place in 3 squares, which we can't do. So this has to be already a 1, 2, or a 3, which is pretty good. Which is great. Zoopy, I see a what? Yes, maybe I should address that. Why, as a game dev channel, doing Sudoku? Well, you might see from the title that I genuinely think that Sudoku and these variant Sudokus, they are actually a fantastic way of learning, or just not learning literally what to type in a programming language, but they are fantastic for the logical thinking, kind of problem solving and puzzles that you need in order to write good code and be able to solve kind of the more complicated problems that you'll come across all the time. So just having kind of that built in just through more fun methods, because this is far more fun than hammering away some code, because there's a beautiful puzzles always hidden in here, and just being able to think through it, think logically, deduce things, it's beautiful, and hopefully you'll be able to see that. And I'm already seeing here that if this has to be 1, 2, or 3, then we just went over the rules of this dot. So we know some of the numbers that this has to be now. So the 1 could become a 2. The 2 could become a 1 or a 4. And the 3, well, we can't half the 3. So the 3 is going to have, oh, whoops. The 3 would have to become a 6. So now we only have these. And it's also kind of interesting that this dot leads into this dot. And because there's kind of this little chain here, it goes around a corner, but it doesn't matter. There's 3 numbers here that all have to be multiples of 2 apart from each other. And what's interesting is if we just consider this square, and let's just say it's a 2 for now, that this number has to be either half or double it, and this number has to be either half or double it. And they can't be the same number because they're in the same box here. So I think this means, and this is really nice, I really love this, and it's definitely, I assume, the way to start the puzzle, because this is a great little thing down here, that you have to have numbers that are one number and then double it, and then one number, double it again, or one number, double it again, because there has to just be an increasing doublage going on, because whatever this is, we have to have whatever's half it and whatever's double it, because we can't have the same, we can't have both of these being double or both of these being half. So what numbers actually fit that? So we have 1, 2, and 3. Like 1, 2, 3 like this would work. 1, 2, and 3, apologies, 1, 2, and 4, so that could work. But we just said 4 can't work because of if this bulb logic, so it's actually, this isn't 1, 2, and 3. What else could work? So if we start with a 1, this has to be a 2. If this is a 2, then what could we have? They have to double or half as we go along. So it couldn't go 2, 1, because then we'd have to put a half here. So that doesn't work. So otherwise it's 2, 4, and then 8, which also doesn't work. So I actually think it has to be 1, 2, and 3, with the 2 here, and a 4 and a 1. And we said the 4 can't go on here, so that's a 4 and that's a 1. And I think just like that, we're away a little bit. We've got a few numbers. And hopefully that logic made sense, that it kind of has to keep doubling along here, and we can't put a 4 on here. Okay, so what's left then? So in this box we have 3, 5, and 6. Okay, and I don't think we can really do anything too much with that. Not yet. We can't figure this out quite yet. But what else have we got? So we got this same thing. And let's say that also... Oh, actually, no, this is perfect. So what did we say before? Numbers on these bulbs, because this has to be at least 6, or at most 6, at most 5, at most 4. So this was 1, 2, and 3. But we've already got a 1 and 2 in this row. So I love that this has now immediately given us this, which immediately gives us the 3, 4, 5, and 6, because this is the only way. It's the example I did earlier. I didn't know this was going to happen, but this is the example I did earlier when I was explaining the rule. It has to go increasing 3, 4, 5, 6, because otherwise you couldn't fit the numbers on the thing. So that's fantastic. And now, yeah, you can see this can't be a 5 or a 3, so this one's a 6. This can't be a 5 or a 6, it's a 3, and this one has to be a 5 to finish the box. That is beautiful. Yeah, Zup, you're right, it was 1, 2, or 3, and we solved it immediately. Oh, this is so cool. Okay, so what's left along here? 1, 2, 3, 4. Well, I can see a 4 has to go in this row, and it's very obviously not there. So this is a 4, which makes this a 5 by elimination. So what finishes along this row? It's a 1, 2, 3 we got, 4 we got, and a 6. Okay, so none of those are doable yet, I don't think. I'm not seeing anything. I'm not seeing anything immediate. So... okay, well, we know this can't be a 5, right? Well, obviously, because there's a 5 there. But because if it was, then this would have to be a 6, and then there's no value for the end of the thermometer. So I'm just trying to think what values can go on the end and what values can go on the start. So if this, at minimum, is 1, 2, 3, 4. So I think that means this has to be 4, 5, 6. So, oh, you're right, yeah. So we can't put 1 at the end, because how can you increase to get to 1? Well, actually, does that mean the 1 has to go on the beginning, which did work out. But if there is a 1 on a thermometer, it has to go at the start. So that's cool to know. Maybe for a future puzzle. We've got a few more that I've collated, hopefully. But you know, if there's any more that anyone else has, send them in as well, because I just want to solve all these fun puzzles. So this is now definitely a 4 or a 5, which means this has to be. Well, it's not a 4, so this isn't a 4. Can this be a 2? Well, no, this can't be a 2, because then what goes here? It would have to be greater than 1 but less than 2, and not 1 or 2. So that doesn't work. So it's not a 2. Could this be a 3? Yes, this could be a 3, because we have a 2 and a 4. So in my head, at least, this now has to be 3 or 4 or 5. But hold on, it can't be 4 or 5, and it can't be 6. So I think this actually has to be a 3. That doesn't help us fix if this is a 4 or a 5, but I think this does give us a 2 here, because what else goes between 1 and 3? So we've got some numbers more up here now that we can finish off. This is 1 and 4, which is nice. And anything else? Oh, this has been here for a while. Maybe this hasn't been here for a while, but we got it now. What can 3 go on a dot? Well, one of these has to be bigger, like double or half the other one. And what's half of 3? 1.5. I can't put 1.5 in a square of a Sudoku, so it's going to have to be a 6. Which removes a 6 from here. Yeah, I suppose. So what else? What else have we got? But a 6. I'm seeing a 6. You're seeing a 6 somewhere. I'm not seeing a 6. And other side 6. Where is this 6 going? That would be very lovely. But I think maybe it's just by regular Sudoku. I haven't actually done any Sudoku. Yeah, no, you're completely right. I can just put a 6 here. So I forgot regular Sudoku. Normal Sudoku rules apply. So we can just solve it by Sudoku, and I think that's fair enough. So does that also give me a 6 up here? You got it. Hey, awesome, thank you. So I don't think I can Sudoku another 6. Can I Sudoku any 5s? I mean, I can get a 5 here. I don't know if that's tremendously helpful. Not yet, anyway. We'll just do a quick check. Yeah, I can put a 4 here. So that's great. Does that give me any other 4s? Yeah, it also gives me a 4 here, which gives me a 5 here, and a 1 here, and a 4 here. That was insane. that just solved a lot of things immediately. And I don't think I can Sudoku much more, but I don't think I actually need to, because that's just given me so many digits. Let's work out the consequences, so we don't want to forget anything. So we got 1, well, a 2 has to go in this column, and it can't go here. So that's 2. And then 3 is the only thing left. Along here. So we have 1 and 2, 3, 4, 5. But this one can't be a 5, so that's great. Oh, that's a 1 and that's a 5. Oh, which means this now has to be a 2 to fill in the rest of it. This is now a 1 and 6. And unfortunately, I don't think I can finish either of those yet. There's nothing that gives that away. 1 is in the left middle box. Oh, fantastic. You're completely right. So yeah, you can see. So there's only one number left that isn't in this box, and I just missed it. Which means there's only now 1 left here, which is a 2, which is brilliant. So what numbers are left to go in here? In the box, at least. 1, 6, or in this column, sorry. 1, 6, and 3. So I can't put a 1 because it would have to go with a 2. And the 2 isn't on here. So it has to be a 6 and 3, and the 6 can't go there. So that's a 6 and that's a 3, which makes this a 1 and this a 6, and I think that's going to basically solve the whole thing now. So yeah, this has to be a 1, that's a 2, that's not a 2. Ooh, have we messed something up? Because there's no 2 in this column. Oh no, there's a mistake here. I've made a mistake. Really? Oh, everything I did felt kind of reasonable. Yeah, no, there's a problem here. I don't know how far I need to go back. Oh no. Okay, well, you know what? This is fine. I can technically cheat and find out. I can press this button and it will tell me if the numbers that I've got in the grid are right. But so yeah, this is the problem here, is that you can see I've got a 2 and a 1 here. So where does a 2 and 1 go in this column? Well, obviously not here. So that would make these have to be a 2 and a 1. But if these are a 2 and a 1, then it's clearly not a 6. The 6 goes there, and then this isn't right. So maybe my logic with this was just wrong, and I missed out some numbers that can go in there. Because I said this had to be a 6 and a 3, right? Something like that. So let's see, am I right up to here? No, I'm not right here. How far back am I going to have to go? This is not what I was hoping for. I'll be honest. Be honest with you, I wasn't expecting this. But it's all good to sometimes spot the mistakes. I mean, hey, this is bug fixing. This is bug fixing now. Not in the traditional code sense, but you do need to go back and find your problems and figuring out why you logically made those problems instead of just undoing everything and starting again. Although undoing everything and starting again is a perfectly valid reason, and it's actually quite helpful sometimes when you're just so confused. But this is a simple problem, so we should be able to just figure out what went wrong. So we've been wrong for a while, actually. I want to find the digit that was wrong and why it's wrong, because I can't see any like forced thing that was wrong. The digits are correct here. So is this one wrong? No, that's correct. That's correct. That's wrong. So why did I put a 4 there? That's interesting. I actually don't remember. I think I did it by Sudoku. because the 4... Yeah, because there was like 4s here and 4s here, so the only place left for it... Oh, wait. I'm so silly. No, it could be either here or here, and I just put it there. That was a really, really stupid thing to do. Top left is 5. Top left is 5. Where are we seeing top left is 5 from? One is in the left middle box. Yeah, so we got all this. Top left is 5. Oh, it was just from earlier. We're using our logic from earlier. Fair enough. Okay, thank you. I think I wanted to try and re-logic myself from here. What's left to go in here? Oh, this has to be a 1. This has to be a 3. This is a 2. This is a 1, 2, 3, and 5. I think we're still fine. I mean, these are 3 and 5 now. Because these are 1 and 4, yeah, I could have got that. Oh well, this is the 2. We still know that. These are 1 and 5. It's a shame we have to roll back our logic here, but it won't take too long, hopefully. So this is still a 4 and a 5, and I can't solve that. 4 is on the last part of the line. Yeah, it feels like this would be a 4. Because where's the 5? The 5... Well, the 5 could come here. I mean, we know the 5 can't go on the dot, because you'd have to put 2.5 or 10. 4, 5 is 4? Yeah, no, sorry, that's what I meant. So this feels like it's a 4. That's not what I said. But I want to just check why it's a 4, just really quickly. Because these can't be 5. So the 5 and these are both 5 and 4. I think we figured that out. 5 is above, yeah. So this is 4 and this is 5. But why? I mean, we got it before, and that wasn't the problem before. Or this was where I went wrong. So, but the 4 and the 5 this way around was wrong. It's kind of obvious that 5 is above 4, 5. No, oh, I'm sorry. Yeah. Okay. I think I just misspoke. Apologies. To complete this column, this is a 1, 2, or 6. This is actually a 1, 2, and 6, right? This kind of triple here, but this isn't a 6 and this isn't a 2. This... Maybe I just have to do some Sudoku. I haven't actually done that in a while, have I? Yeah, the 4 was the mistake before. But I don't want to figure out the problem just by I made a mistake, so I know it can't be somewhere. So where else is it? I'd rather just figure out how it was meant to be put there. Because that's the only logical way of doing it. Oh well, we know oh, actually, this is perfect. Where does the 3 go in this box? You can see the 3s are ruling out here and here. So the 3 has to go on the dots, and a 3 on a dot has to go with a 6 because we can't put a 1.5 there, and a 6 can't go there. Oh, it's taken us a while. Oh no, I just said exactly the wrong thing. But it's that. Oh, which gives us this, 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 and this, and this, and a 5, and a 4, and a 3, and a... Oh my god, this is everything. 4, confetti, and we're done! That just blew up! That was crazy! I don't know where that really came from, but we solved it. Hopefully that was a cool... I think this break-in at the beginning, this was really cool, especially with the thermometer logic that gave us this like kind of X in the middle. It's a shame we made a mistake because that was a really beautiful puzzle, but it was really fun. And that now means we can move on to the next one, which is... This one's called Unique Dominoes, and I believe it's a 4x4 puzzle, so it might even be slightly easier. We have every... Oh, yes. Oh, I wrote this down. Saved this one because this was cool. The rules were crazy. Can you read this? I think you can. But if not, the rules should be on the play screen, hopefully. Yeah. Every possible domino. So, oh, this is a different website. Hold on. Apologies. Let me just adjust things so you can see them better. I think that's about as good as I'm going to get. So every possible domino, pair of distinct digits, appears exactly once in the grid. For example, no cage with the contain 2 and 4, or one cage contains 2 and 4, and no other cage contains that pair. So what does this mean? If you've got kind of a bag full of 1 to 4, and we take 2 numbers out of it, then what are possible 2 numbers we could get? We could get 1 and 2, 1 and 3, 1 and 4, and then 2 and 1, which we've already had because it's all the same as a 1 and a 2. So those just cancels out. 2 and 3, 2 and 4, or a 3 and a 4, because the 3 and 1, 3 and 2 we already had, just the other way around, because permutations don't matter for this problem. So we just have all the kind of combinations of the numbers 1 to 4 once in these dominoes. And you can see the 2 and the 3 here. This one's already done, so I can't put a 2 and a 3 anywhere around in any of these other dominoes, if I've understood the rules correctly. And that's it, that's all the information we have, but it is a 4x4. It is a 4x4 grid, so I'm hoping this won't be too difficult, but I just thought this was really cool. And it's actually perfect for programming, because dealing with combinations, permutations of sets and numbers and randomness and whatever comes up all the time. So that's pretty cool. Now, one thing I know just from these pairs is that each one of these numbers is used 3 times. If you just looked at all the pairs, well, a 1 can go with a 2, 3, and a 4. A 2 can go with a 1, 3, and 4, etc. So each of the numbers is used 3 times in a domino. So you've only got 2 more 2s and 3s, and then, 3 more or 2 more 1s to use, etc. Stuff like that. But just by regular Sudoku, we can see that these, because we've used the 1 and the 2, these are 3 and 4. And because these are 3 and a 4, neither of the, well, it could be 4 and 2, I suppose, but because these are 3 and a 4, these are 1 and a 2. And a 2 can't go with a 3. We know that because of this domino. It wouldn't be unique. These are also 3 and 4. Purely because there's a 1 and 2 in this box already. So we've got some numbers. Oh, well, this can't be a 3. So just right away, without any of the domino logic, that's a 4, and that's a 3. So that's pretty good. We've got that already. And now by domino logic, this is beautiful. If this is a 3, this can't be a 2, because you've already got the 2, 3 domino. So this has to be a 1, which now means this couldn't be a 1, 3 domino, because we've already got it. I mean, admittedly, we already know this isn't a 1, 3 domino, because there's a 3 there, but ignoring that for now. So this must be a 2. And, oh, because there's one of the numbers 3 times in the dominoes, that means there's one number, one occurrence of the number, because that's not in a domino, which means these corners have to be one occurrence of the digits 1, 2, 3, 4. And we've got a 2 and a 4 in the corners already. So these are 1 and 3. But this one isn't a 3. So this is a 1. Oh, I knew that anyway. I'm so blind. That was already the only number left. Whatever. We can get this as a 3 though, which is pretty cool, just by using the counts. And I don't think we could have got that otherwise, which makes this immediately a 4 and this a 3. Oh my god, this is so good. So 3 now, it's been seen a 1 in a domino, it's seen a 2 in a domino, it can't see itself in a domino, the only other thing is a 4, which gives a 2 here to complete the thing, which gives a 4 here to complete the row, or to complete the column, and then we complete the row, and then we complete the column, and we're done! What a beautiful puzzle using just some combination logic. I hope you managed to follow along. That one was beautiful, and almost purpose-built for programming. That's kind of actually perfect for this. Beautiful, beautiful puzzle. So what's next? What's next? Well, up next is called zippers and circles. This is confusing. I'm happy to explain it slightly more. I think that logic made sense. But this is a very unique Sudoku. I've never seen another Sudoku with these rules before. If we move on to the next one, this is a more standard, I say standard variant Sudoku. It's a more standard variant Sudoku, I suppose. It has rules that are the same. So, normal Sudoku rules apply. Place the numbers 1 to 4 once each into every row, column, and box. So that's just the regular Sudoku 4x4 box stuff. Hopefully we've got that so far, which is pretty alright. I like Sudoku and this is hard. Yeah, variant Sudokus are weird, and it's kind of interesting because I'm not that big into Sudoku. I only started a few weeks ago, but I just thought these, as soon as I came across these variant ones, I just thought they're so beautiful. I need to do this. It's just a great little practice, great little problems, and it just works your brain in such a different way. And all of these have been so unique so far. I haven't done any puzzle that's felt even remotely the same as another one. So we need to place the numbers 1 to 4. So we know that bit. Digits an equal distance from the center of a great zipper line, which I'm assuming is these things. So there's one there and there's one there. Must sum to the digit in the center of the line. Ooh, what does that mean? So that means that if this was a 3, these would have to be a 2 and a 1. So these would have to be a 2 and a 1, something like that. Well, actually, I think right away, I'm not going to read the rest of the rules quite yet. That means this can't be a 1 or a 2. If this is a 2, oh wait, no it can. This could then be a 1 and a 1. So I'm going to actually undo everything I just said, because it didn't make any sense. Why can't I delete this? Is my keyboard broken? I think my keyboard just ran out of battery. That is quite a wonderful way to, roll credits real quick. Okay. But we can read the rest of the rules while we're doing that. So a digit inside a circle indicates how many circles that digit appears in. Huh? A digit inside a circle indicates how many circles that digit appears in. So if there was a 1, are we gonna work? Okay, let's just use my laptop keyboard instead. So if this was a 1, I think that now means that no other circle can have a 1, because there's only one circle and a 1. If this was a 2, then there's 2 circles, so there'd have to be maybe this one is a 2. But now none of the other ones are 2s. And then if this was a 3, with the confetti again. If this was a 3, then something, maybe this is a 3 and this is a 3. Because it has to be 3 3s in a circle. And then finally, if this was a 4, then we need 4 4s in a circle. So like this. But yeah, as I was doing that, I was starting to think, is it even possible to put 4 4s in circles? I don't think so. Because maybe this one, it wipes out here. And then we have to have one of these circles. Because we can't put all 3 in there, right? So then that wipes out this one. And then we have to put one of them that all wipes out these. So there's only 4 possible, there's only 4 4s that can possibly go. Yeah, this is strange. I don't like this, because if these are 4s, then where can the other 2 4s that have to go in the circles go? I can't put one there. And sure, maybe I can put one there, but then the other one, the last 4, would have to go in one of these, which it can't. So I'm going to say that I don't think a 4 can go in a circle, because if it was here, it already wipes out all of these ones, so they're all gone. If there's any 4 in here, it wipes out all of them. If there's a 4 here, okay, fine, now we have 2 4s. And now the third 4 wipes out all of these. So yeah, definitely we can't put the 4s in a circle, it's not possible. Which has me thinking, where does the 4 go in here? And we just said the 4 can't go in a circle. I think that's pretty good. And I think by the sum logic of these zipper lines, a 4 can't go anywhere other than the center of a zipper line, because the center number has to add up to whatever's on the ends here. And if this was a 4, this would have to be bigger than 4. We can't put a number bigger than 4. So it's not here, it's not here, it's not here. This is a 4. And I'm pretty confident with that. And my keyboard's still broken, but that's fine. I can use my other one. 4 would go bottom left. Yes, so now this 4 wipes out a 4 from here. We know a 4 can't go in the circle. That's a 4. So we're actually doing quite well, I think, already. So now we also know that all of these have to add up to 4s. Can we do anything similar now with the 3s maybe in the circles? I think we said 3s in the circles is possible. If we say, well, all of these numbers now, whatever these are, the kind of opposite number, the 4 minus that number has to go in these. And if we said this was, if this is a 1, this is a 3, but we've used our 1 in the circle, which I think is quite restrictive, so I don't really want to put a 1 in a circle quite yet. There's no Sudoku magic to be done. I mean, other than a 4 is kind of one of these, which doesn't feel that helpful. And if a 4 is one of these, can a 4 come here? Well, if a 4 is here, we need 2 and 2 or 3 and 1, and both of those seem pretty reasonable, so I'm not ruling anything out yet. Let's look at 3s. So if this is a 3, this would have to be a 4, because then this would have to be a 1. If this was a 3, this would have to be a 1. And if this was a 3, this would have to be a 1. I don't think I can't say with 100% certainty, I don't think. There's nothing there. Nothing quite there yet. What about... So this box has to have 1, 2, 3 and 4 in, just by regular Sudoku. And if this was a 2... Oh, got it. Yeah, nice. Cool. Maybe hopefully just pause a little bit, see if you can get it as well. But if this was a 2, it has to sum with a 4. Digits in equal distance from a zipper line must sum to the center, right? So this is a 4. Whatever this is and this have to sum to a 4. And if this was a 2, that would make this also have to be a 2, and we can't do that because they're in the same box. Oh, it is. The other 4 would have to be part of a 1, 2. Yeah. So this is 1 and 3, this is 1 and 3, and this is a 2, which is really cool. And that wipes a 2 out of these circles. Which I don't think we can use anything with that for now. But that was still cool. So, now there's no 2 on the end of here, which I think means the minimum. We know a 4 can't go on here, and it can't be a 2 either, so this is now also a 1 and 3 pair, which it doesn't matter which around these are, that's going to add to 4, which is fantastic, which means also that's a 4 just by Sudoku. So that's actually really good now. So we've got all the 4s, and we have these 1s and 3s are kind of interesting. 4 is middle? No, I think we got it. We got it. Yeah! We can cheer out. Yes, no, we got it. It's pretty awesome. What's left? What's left? What's left? So, 2s. The 4s are done. There has to be 2 2s in a box. But I don't think a 2 can go in any of these boxes. Oh no, they could. If this was a 2, this could be a 2, and that doesn't break anything. And then a 2 would have to come up here. No, so that would, a 2 here, a 2 here, and a 2 here would work. So we can't say anything about that quite yet, which is a shame. Oh, I just realised the Sudoku's kind of off the screen on this one because we went back to the other software. Apologies. I've also just realised my face is being covered by my logo, which is quite funny, but oh well. If 3 is in a circle, then it's in top right square, bottom... yeah, okay. That's an interesting idea. So we know one of these is a 3. And we know there has to be... If there is a 3 in a circle... Oh! How many circles are there? There's 6 circles. 1 plus 2 plus 3 is 6. So that means we have to have all the other numbers in the circles, because if a 1 is in a circle, it only gets used once. If a 2 is in the circle, it gets used twice in a circle. And if 3 is in a circle, it gets used 3 times in a circle. And we have 6 circles, so we have to now put all the other numbers in the circles in order to fill the 6 circles that we have, which is cool, which is good. So we know now that the 3s are being used in the circles. And if the 3s have to go in the circles, then if a 3 goes any of here, so a 3 can't go here. If a 3 went here, it would wipe out too many circles. and we'd only be able to put one more. So there's no 3 here. 3 can go here, but if a 3 goes here, then all the other 3s have to go in circles. And if a 3 went here, it would wipe out these circles just by Sudoku. And then there's only 2 circles we can put one in, because we have to put one there and one there. So we'd only get 2 3s in circles, so this can't be a 3. That's a 1, which makes this a 3, and a 1, and a 1, and a 3. Oh, so this is going to solve itself, I think, now. Because we have to get all the rest of the 3s now have to go in circles. And the only circle left in this box, and the only circle... Oh, well, the only circle left in this box is a 3, so that has to go in there, because we have to put all the rest of the 3s in circles. This is 2. I think I just got there before. You said 2, 1, 4, 3. There we go, 2, 1, 4, 3. Beautiful. The 3 has to go in there to finish this. We get the confetti. Lovely. So this is now 2 and 3. This is 2 and 3, but this isn't a 3, so that's a 2. We've got our 2s in boxes now, so this... Oh, there's no more circles, so I think we're actually home and dry. 1, 2, and 1. Yes! Look at that. Lovely, beautiful puzzle having to use the number of circles in each thing. Oh, and like the symmetry of this, like the diagonal. Oh, beautiful. That was really cool. You got it first. You did get it first. No, well done. That's really cool. I like to think we're working together, but that's fine. You want to go ahead and crush me. That's all good. I love it that you get involved and give it a go. I can actually put the links of the puzzles in the chat as well, so you can like properly solve it. Yeah, that's a good idea, actually. Let's do that. So the next puzzle. The next puzzle is what fits in a cage, and this is kind of an introduction to killer Sudoku, which I haven't done. I think I've done one before, one last week. So here we go. Here it is. I'll just put it in the chat if it let. Oh, I tried to use my keyboard that I can't use. That's fun. Okay, here we go. What fits in a cage? So I'll explain the rules once we get into the actual Sudoku, because it will hopefully explain them a little better than I can. So, can we see the whole puzzle? Yeah, we can see the puzzle. That's all good. I can make my face a little bigger here now. Hey! Hold on, I think this should work. That last puzzle was really good. Is it going to work? Are we going to work? Yeah, look. Wow. We get the hearts. That's cool. That is kind of cool. We got loads of other stuff as well we can use, but not for now. Only when we get a really deserved one. Okay, so normal 6x6 Sudoku rules apply, as if 6x6 Sudoku is normal, but at least we've done one now, so we know what to do. Place the numbers 1 to 6 in the things. Yeah, we know that. That's all good. Identical digits cannot be a king... Whoa. Identical digits cannot be a king's move apart, as in chess. So if this is a 2, I'm sure it won't be. I'm taking that to mean, so a king's move, a king can move anywhere kind of orthogonally adjacent, so north, south, east, or west. It can't go diagonally, but it can go... Wait, what am I talking about? It can go diagonally. Ignore me there. I was thinking of a rook for some reason. So we couldn't then put a 2 in any of these. Is that what I'm saying? Which feels actually hugely restrictive when the board is so small. So that's fine. Digits in a cage sum to the number in the top left hand corner of the cage. So this is the killer Sudoku part, which I think is cool. So we can see 21 here. This actually doesn't help us at all, because we know all the numbers 1 to 6 have to go in the cages. Or in each box, the numbers 1 to 6 just have to appear by Sudoku rules. You can see 1 to 6 in each box. The numbers 1 to 6, I mean, I assume they must add up to 21. I haven't done it yet. But yeah, they add up to 21, so that's fine. So you can see these, this one actually now, this is beautiful, yeah. So we just did the numbers in all the boxes 1 to 6, which n plus 1 over 2, which is great if we're going to need that in the future. Yeah, we can check that. So n, 6, n plus 1, 7, 6 times 7, 42, over 2, 21. Boom. I mean, you need that for programming sometimes. It's kind of annoying, but this is good to reinforce it. So this is 20, but you can see it's missing one of these boxes. And if this adds up to 21, this adds up to 20, then what's in this box? It has to be 1, because we know the whole box together adds up to 21. So that's a 1. And the king's move doesn't help us, because that just gives us there's no 1 here, but we already know there's no 1 here, because there's already a 1 in the box. Yeah, this cage is a dead giveaway. There's no 6 here. Well, there has to be a 6 in here, because how do you make a 6 with just one K? Well, it's a 6. It's just a 6. And this box, I'm thinking, immediately is really interesting, because we just did the whole thing has to add up to 21. This little subsection down here is 11. So this adds up to 10. Now, at minimum, with 4 numbers, 1, 2, 3, and 4, that adds up to 10, I think. Yeah, 1 plus 2, 3, plus 3, 6, plus 4, 10. So this is 10, using the numbers 1 to 4. It's the minimum possible to do it, and we have to get 10. So these numbers have to be minimized at 1, 2, 3, and 4, which means these are numbers 5 and 6. And we could have done that logic as well. How do you make 11 with 2 digits? The only possible way of doing it with the numbers 1 to 6 is 5 and 6. And this tells us that this is a 6, so that's not a 6. So that's a 5, and that's a 6. And now I guess the fact that these are the numbers 1 to 4 really isn't that helpful, because we know that anyway, so I'm just going to get rid of that. But that's still pretty useful. So a 6 now can't go anywhere here, and a 6 can't go anywhere here. I don't think that's actually that helpful. Same thing with the 5. It's not that helpful, because we know that isn't working. I can't believe I got the king smooth thing wrong. Yeah, that was outrageous. I play chess as well. Oh dear. Oh, beautiful. Okay, so how do we make similar logic we had to down here, if you can think about it. There's a 6 box here. You're ahead of me, which is good. But the numbers, how do we get 6 with 3 numbers? At minimum, these numbers have to be 1, 2, and 3. And 1, 2, and 3 does add up to 6 if you add them all. So I can't put a 4 in this box, because then the other ones would have to be, both 1s, and we can't do that. So this is 100% a nice little 1, 2, 3, which makes these 5 and 4, because they're the only numbers that are left. And there's probably something similar going on here. So yeah, okay. The total for the 21, the whole box is 21. These numbers are 18. What's 21 minus 18? 3. So these numbers have to be 3. And the only way to do that is going to be with a 1 and a 2. And just some Sudoku knowledge now. We know that this row, we don't know where the 1, 2, 4, and 5 are in this row, but we do know that they're kind of at least here. So what's this row missing? And although we don't know where the other digits are, we do know that this is a 3. Because we've got a 1 somewhere, we have a 2 somewhere, missing the 3, have a 4 and a 5 somewhere, and we got the 6. So this is a 3. So is this now telling us we need to make 15 with 3 digits? I think that now has to be 4, 5, and 6. Actually, we know it has to be 4, 5, and 6. But if you just look down here, this 11 cage is like the maximum 2 digits can add up to, and it was 11. And we just add 4 to that, which is the next smallest digit, and we get the 15. But also, just by Sudoku, it has to be 4, 5, and 6, because we've used the 1, 2, and 3 down here, so these have to be 4, 5, and 6. Yeah, so that's good, that's good. And then I think the exact same logic, this has to be 4, 5, and 6, because that's how we add up to 15. We just did that, which means these are 1, 2, and 3, because they're the only numbers left. And if these are 1, 2, and 3, this is 4 and 5. This is 5 and 6. This has to be a 4. Oh, this is amazing. This is really, really good. Oh, and that gives us a 4, 5 there, 4 there, which gives us 5 here. This is crazy how this is coming together. 2 here. That takes a 2 out of these boxes. That makes this a 6. That takes a 6 out of these. That takes a 5. Oh, it takes a 5 out of these. So that's some good stuff. Okay. So these cages are actually useless now, because we know this added up to 21 anyway, and we know this added up to 20 anyway. So that's useless. I think we're almost kind of out of the cage logic, and we're just regular Sudoku now. These have to be 1, 2, and 3, because we've already got the 4, 5, and 6. We kind of got this like wave effect. We have 1, 2, 3s, 1, 2, 3, 1, 2, 3, 1, 2, 3, which is really cool. And it's kind of looking like it's going to be 1, 2, 3, 1, 2, 3 again, or 1, 2. That actually breaks at the top, but that's fine. This is fun though, because it's 4, 5, 6, 4, 5, 6, 4, 5, 6, 4, 5, 6, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's beautiful. It's like stripy. I almost want to like color it in, but we'll solve it first. Okay, so So the 4 isn't here. The 4 is 1 in here. We can't place anything else though. Maybe let's just try some Sudoku. How dare you make me do a Sudoku in a Sudoku puzzle. The 15 box is 654. Yes, we got that. Unless you meant 654. So I have 5 here. Was that wrong? Doesn't look quite right. Okay, well I think that's just because it's not finished yet, not because it's wrong. You already got it. Okay, thank you, yeah. Bit of a pause is okay. I mean, sometimes the best thing for programming is just take a step away for 5 minutes and come back. I suppose I don't have that luxury. But this does feel very, like, just unsolvable. I don't have, there's no more information. Like, this is useless. It doesn't really tell me anything. Nothing's like, that. Not, yeah, these cages is useless. And all of this information is useless. So this is going to be a tricky one now. And if anyone can let me know, or if anyone has any ideas, someone sees it. Yeah, we're in this together now. We're 9 minutes in, which isn't terrible. I'd like to normally get it under 10, 15. So let's say 15, we're against the clock. Maybe we have to do some column logic, but I'm not seeing any column logic that's really helpful. Because, I mean, we just don't know anything about the top. Oh, the king's move! I've been ignoring the king's move. Yeah, let's use the king's move. How about that? We don't ignore one of the rules. So, immediately, right, these are 1, 2, and 3. Which means these can't be 1, 2, and 3. No Face, nice to see you. I like the name, that's pretty cool. Don't know how to play Sudoku. You know what? That is perfectly fine, because neither do I. I'm just a complete beginner to variant Sudoku, but it's just kind of genius and really beautiful how the puzzles come together, and it's really good for the problem-solving part of programming, which doesn't maybe get shown enough on Game Dev YouTube, because it's just, you know, it's the boring side, but I think it's the beautiful side, and we're going to make it better for everyone, just by having fun by accident. You're gonna learn, hopefully, to pick it up while having fun. And you've come at a sticky time, actually. We're a little bit stuck on this puzzle, and this is a Sudoku where the numbers have to add up to the numbers in the cage in the top left. So this was 11, so that means this had to be 5 and 6, for example, to kind of add up to what's left. And using just that, you can solve the whole thing, which is really cool. If you think about it, just the idea that that works. But it does. Hopefully. I mean, I've been told it works, but I haven't been able to do it yet. It's been a long time since I saw any content of yours. Yeah, no. So that is because I'm currently studying at uni. I'm in my 3rd year. It's almost coming to an end now. Just got my exams left. And then a 4th year, because no, it's been beautiful. I was going to make some joke, but it's been really fun. 4th year, so I'm going for my master's in computer science and mathematics, which does slightly put a strain on how much YouTube game dev stuff I can do. Although if I could, I would do it all the time. It's my favorite thing to do in the world. But hopefully, these streams, they take so much less time to edit. So much. I mean, I love putting in the effort editing, but it really restricts how much I can do. Whereas these streams, I can just hop on, do some Sudokus, chat with you guys, and I can actually get some content out on the channel, which I think is fun. I'm going to actually do some game dev live streams, hopefully, as soon as I've just kind of set up what would be best and what I think I can do in a way that's fun to interact with people. I think what I'm going to do, actually, is a little sneak peek for next time. I've picked up is the box around here somewhere? Not sure. I've picked up ignore that. Where is it? Yeah, here we go, a capture card. So I can record my Switch, which was the main goal, but anything else as well, really. And I want to just kind of play. So the reason I got into game dev is because I saw all these games that I'm playing, and instead of just being able to enjoy and play them, I just get so distracted by like, oh whoa, that on-off block in Super Mario Maker. How the hell does that work? And I'm like, okay, well, I need to remake it. And that's just how I've kind of learned everything game dev, and pretty much all my programming ability at all has been, there's this really cool thing that I've seen and enjoyed using in a game. How does it work? And by asking that question and then just figuring it out myself and just trying to solve that has essentially been everything for me, and that's how I've learned everything. And it's super an amazing way of learning, and I really want to bring that to other people that maybe ask those same questions but don't know how to get started and don't have the confidence to give it a go. I want to give people the confidence to give that a go. So what I'm going to do, the reason I got the capture card is so I can set up just Switch games. I'm going to be doing 51 games, like board games and stuff to begin with. Mario Maker that's my like big love. I know I started game dev. That was like the one thing I said I was going to make my YouTube channel all about, just remaking Mario Maker. That was like the one thing I wanted to do. And then I realized it meant I had to make a platformer. And that's just kind of overdone, let's say. I'm not a huge fan of making platformers. My currently in progress commercial game is a platformer, but that's only because it was really unique and cool. And there was like a new spin on it with Seamless, if you've seen that on the channel. But other than that, I don't love making platformers. I love making everything that goes with a platformer, so like the unique enemies, the motion, like the ways of moving around a level, different mechanics and interactions and stuff. But it's just not for me. If you want to make a platformer, you can make a platformer without my help. I want to bring something new. And the way I do that, hopefully, is we'll just play something on the Switch. We'll have the game on the screen, and then we can answer those questions of how do we remake it literally live together while we are playing the game, which I think would be really fun. I'm really looking forward to it. So we're going to have, maybe Mario Maker on the left-hand side with the code on the right-hand side. Something like that. I want to see how it goes. So I need to figure out how to do that, and then I'll be with you as soon as I can. I want to try coding, but I can't find any good tutorials or anything like that. Well, shameless plug, I suppose, but I have quite a few programming tutorials. I just put one up on the channel recently about making tic-tac-toe, which I think is a really fun one. It's a good way to start making anything with something you're already familiar with, because if you start making something you also don't understand, well then you've got to figure out, one, how to understand the thing you want to make. Like, I don't know, you say you want to make a racing car game. You're going to have to figure out how cars work, physics work, steering controls, everything, drifting, traction. Forget about all that, I don't care. Let's just make something to begin with, nice and simple, that we already know about, how the rules of the game work, tic-tac-toe, and then the only thing you have to worry about is learning how to write the code. Then once you've done that a few times, you'll figure out how you can take something that you do know, make code out of it. You've got the code side down. So then once you've got the code side down, you can make the new thing actually learning something new. So you don't have to do two things at once. It's really helpful. So that went up on the channel a few days ago, which I'd recommend. I've also got a few more. But if you're looking for just general programming, who I can recommend, CodeMonkey is fantastic for Unity, along with Brackeys, although RIP Brackeys, it's so sad, he's gone away. So that's if you're interested in kind of C# Unity. If you've got no kind of ideas on what type of programming you want to do, be it games, web development, general programming, anything, or engine and language you want to use, I'd recommend Python, just purely because it's going to be nice and easy to get going with. And you can make games in Python as well, so that's what I did the tic-tac-toe with, was in Python using Pygame, and it's all lets you do everything by itself, and it's definitely not the easiest way of making a game, and if you just want to make a game, I wouldn't recommend it. But if you do want to learn programming, I would really recommend it. It's really good. It's really good for that. So yeah. Who else is there? Who else is there for just getting into coding? I'd stay away personally from any kind of more complicated ones. Definitely just stick to learning something like stick to something you know, and then figure out how to code that. If you don't know anything, which is fair enough, honestly, because coding is very intimidating, hopefully I can give you the one thing is that it's not as intimidating as it should be, as long as you can find someone that works for you. Tech with Tim is fantastic for his Python tutorials, and he's kind of where he's where I started my Python from, actually. There's stuff like Project Euler and Advent of Code, which are things that I do every year, which is Advent of Code is like an advent calendar thing where every day you'll be given a new problem to solve, 1 through 25 of December, and they get kind of progressively more and more difficult. And you can ignore the difficult part. You can stop at day 5 or day 2 or whatever if you want to, but they're just a really, really fun like story way. Like, gives the whole story that you solve as you go through, helping elves save Christmas essentially. And the puzzles start quite simple and approachable, that you can just go with no knowledge at all and figure them out, and then you just build on yourself as you go, getting slightly better. I had never written any Python before ever. A few years ago, before coming to university, I did Advent of Code for 1 year, immediately knew enough Python and was good enough to do everything I needed at uni, which is a pretty good standard. Which is fantastic, honestly, just from one thing, and I loved the whole process. It was really fun. So I just find ways of making it fun. If you do come across any coding tutorials that you might be interested in, let me know, because I've probably watched them as well, and I can give you my opinion on them. Okay, back to the puzzle, and I have had another breakthrough. I haven't just been chatting a load of rubbish. I have been thinking as well, and I think I've got something. So, what can this square be? We know from the column it has to be a 4, a 5, or a 6, because that's what's missing from the column. Now, I'd completely forgotten about the chess move rule constraint, but let's just use it now. If this was a 4, neither of these squares can be a 4. Oh, it actually has that built in, which is beautiful. But yeah, if this is a 4, none of these squares can be a 4 by chess moves. So identical digits cannot be a king's move apart, which means both of these would have to be a 5, which doesn't work. And I can do the same thing for a 5. This is a 5, there's no 5 here, and both of these have to be a 4. Doesn't work. This is a 6, which means this is a 4, which gives us a 5 here, a 6 here, and a 4 here. Which all of a sudden this puzzle now looks a lot more solvable, and I feel a lot better about it. Oh my god, exactly, I know, right? That was beautiful. I wasn't expecting anything like remotely close to that happening, but it just did. It was so good. No, hey, not smart on me. It's smart on the puzzle creator. It's just beautiful, and this is why I do these things. And I'm nervous because I've never done King Sudoku before. So like something's going to happen where I'm going to need to do something like that again. And I only saw that one after like 10 minutes of talking about game development. So hopefully we can get another one. Because there's a lot less information about the rest of this now. Because this was the only column that we knew kind of most things about. Whereas we've run out of luck. So 6 just by Sudoku can't go here or here. Oh, actually by just complete Sudoku we can get a 6 here. That's nice. So is that all the 6s? That is all the 6s. Woohoo! Why don't we get confetti for that? That'd be good. By Sudoku again, we can rule out 5s from here and here. So these are 5s. I'm just going to do Sudoku. So these are 5s as well. Oh, but this one can't be a 5 by King's move. Oh my god. This gives a 5 here and a 5 here. Now we're getting somewhere. So this one is really interesting. This one's cool. And I should have pointed this out earlier. I saw this as well when I saw this, but I forgot to mention it. This can't be a 1, 2, or a 3, because if it is, it wipes out. So whatever's here can't go anywhere around it by the beautiful King's move. Which means if this was a 1, then a 1 couldn't go anywhere here, or a 2, or a 3. And well, that's ridiculous. There has to be a 1, 2, or 3. So this is a 4, 5, and 6. But now we've got the 5 and we've got the 6. So this has to be a 4. Which makes this is still a 1, 2, 3, but it's not a 1 because of this one. So we also have 1, 2, 3s here. So this is interesting. Whatever's here. Oh, whoops. whatever's here can't go here and here. So it's the same as this, I think. So these two are the same. Does that mean anything? I don't know, but it's kind of interesting. And then this is also 1, 2, and 3. Whoa, that was colours, not numbers. But that's not a 1 as well. Oh, actually, yeah, where does the 1 go? The 1 has to go here, which means the 1 goes here. And the king, this 1 king's move knocks out the 2 from here. That 2 king's move knocks out the 3. That's a 1 now. That's a 2. That's a 1. Oh my god, I think we just solved the entire thing. Oh, wow. Okay. 1, 3. So literally just this little bit of colouring just solved the entire puzzle. That's absolutely insane. 2, 3. Whoa! Oh my god. How amazing was that? I love that puzzle. That was great. I did actually have a few more in the bank, but we're at an hour, so if this one looks quick, I'll give it a go. If not, it's going to be a teaser for next time, because I don't want to be here for too long, because I have exams, still being at uni, but not too many left. Okay, well, hold on. This one's literally called Speedrun Sudoku, and I'm in a speedrun, so I think this is perfect. Let's give it a go. It's a 4x4. Oh, it's tiny. That's easy, 10 seconds. Let's just do this immediately. Normal Sudoku rules apply. Thermometers. Digits on a thermo strictly increase from the bulb to the tip. So that was, you've seen this before, that's fine. Crop key. Digits separated by a black crop key dot have a ratio 1 to 2. One is double the other. So we did that before as well. We know these. And the ratio of 1 to 2, digits separated by a white crop key dot are consecutive. We haven't seen this one today, but we did see this one last week. If you missed it, I'd highly recommend going and watching it. That was a really fun one as well. So these are consecutive. So if this is a 3, this keyboard doesn't work. If this is a 3, this is a 2 or a 4. Nice and simple stuff. So I think immediately this is like actually ridiculous. This really, really, really is a speedrun Sudoku. I have to place the numbers 1 to 4 on this thermometer because it's an entire row. But the numbers also have to increase. So the digits on the thermo strictly increase. So this is the smallest and this is the biggest. Well, how do I arrange 4 numbers so they increase all the time? There's only one way of doing it. It has to be 1, 2, 3, 4. 1, 2, 3, 4. There's nothing else I can do because, I mean, by Sudoku this could be a 3, but then this would have to be a 4 and this is a 5 and it just doesn't work. It doesn't work. So that just gives away everything. This is now a 1 and a 2. Yeah, okay. This is a 1 and a 2. Oh, okay, well that gives it away. I was going to do something so much smarter. I was going to say this is a 1 and a 2. And if this was a 1, this is a 2. And also, if this was a 2, this is a 1. And the only thing consecutive to a 1 is a 2. You know what? That doesn't actually do anything. Whatever, this is a 1, this is a 2, which makes this a 3. This is the speediest speedrun Sudoku ever, and I'm taking ages to solve it because I'm talking about it, but this is ridiculous. Yeah, this is a 3. What kind of a Sudoku is that? That was so quick. I was not expecting that at all. I could probably have solved that in about 10 seconds if I wasn't chatting. Let's go. I don't actually let's restart. Okay, we're gonna go. I don't remember the solution at all. Start the puzzle. So immediately I spotted this has to be 1, 2, 3, and 4 because how else do you put numbers ascending from 1 to 4 on a thing? These now have to be 1 and 2, and the 1 can't go here. So this is a 1, 1, 2. To finish the row, this is a 3. This has to be 3 and 4, but to finish the thing, this is a 3. No, this is a 4, sorry. To finish the box, this is a 4. This is a 1, and this is a 2. 19 seconds. That's more like it. That's good. That's great, actually. That's hilarious. Save the file. Okay. Wow. Well, I said I wanted to finish on a quick one. That was actually kind of perfect. I genuinely did not plan that, although I wish I had. I've actually only got one more Sudoku in my list, so how's everyone feeling? Would you like one more Sudoku? Let's give it a look. Oh, no, this is going to be a long one. It's a 9x9, and it's a whole new rule set that I haven't seen before. Oof, this is a beefy one that I maybe should save for next time. Super, that is true. You're the only one here and you said yes. So I feel like that does mean quite a lot. But this is a big one. So, I I shouldn't have said that. I should have just ended on a high with this with the speed run. I think I am gonna have to end it there because I don't have that long. I'm very sorry to have let you down like that, but hopefully you can come around and stay here for next time. And I hope you've enjoyed solving these Sudokus together. I think they've been some beautiful puzzles, some stuff I've never seen before, and it's been really cool. 100% of people say yes. You know, I can't argue with the fact 100% of people said yes, but I suppose this isn't a democracy. I wish it was, but unfortunately I just don't have time. I had maybe like 10 more minutes. I had to stop at 3. I don't think I'm going to solve this in 10 minutes, and I don't want to like half solve a Sudoku. But I will give you the link if you want to give it a go, and then you can come and complain about how terrible I am tomorrow. It's actually probably going to be next week now. But here's the Sudoku, so please give it a go. But if you solve it, then you can watch me pain and suffering trying to solve it by myself. And you'll be able to understand the rules as well, which is probably a good start, because I don't understand what these black dots mean. And also, there's like no information. I have no idea what's going on. It's called Cropley Killer in the Clouds. So I'm assuming maybe these are the clouds, but I don't know what that means. Other than that, I hope you've had an amazing time. I hope to see you again at some point next time. And, as always, well, I hope you had an amazing day. I hope you have the rest of your day is amazing as well. Bye, and good luck with your programming. Oh my god, yeah. No, good luck if you find anything. If you do find anything, let me know next time as well, and I'll definitely let you know my thoughts on it and hope it's good. But watch mine. I'm joking, you don't have to. But have a good time. Yeah, see you. Have a good day. And as always, happy coding, everyone. And, well, happy coding for you, but happy solving, everyone. Bye-bye. Well, hold on. Does waving work on the reactions thing? Is something gonna happen? No? Reactions. Hold on, here we go. Right, reactions. Party. Hey! What a way to end it. See you.